Hey, Rodney here. Shall we make a game? Now, last night we started working on a nav mesh importer, and I don't really remember where I got to, but we probably got somewhere good, right? Looks like we were just starting to triangulate. Just in case you can tell, this isn't a great night for capacity. Yeah, we were starting to kind of flatten the list of faces into a list of triangles, so we're kind of like turning them all into fans. Hmm. So yes. Yeah, that's right. Okay. So hang on a second. I am thinking, and yes, it hurts. Ow. So we're in for the vertices. Yep. Okay, we've got A, B, and C faces. Okay, so the next thing we want to do is actually write this to our kind of like triangles array, which we're kind of setting up here. Okay, right, yeah, I remember now, yeah. We're kind of like working for this, we're taking all the vertices inside the face, and then we're cutting two off, and then we're basically fanning them out. So this should be as simple as this. Now I think I was going to do a thing where I copy... Yeah, that's right. Okay, yeah, I was going to do a thing. Hang on. I'm having a bit of a brain meltdown here. What's happening? Right, yeah, so the vertex A is always the first one in the polygon, and then vertex C is the next one, and vertex B is going to be the previous one. So yeah, we're copying C to B and then calculating a new C from the index we now have. All right, that should work. It should work, I think. What I could do instead actually is that... No, there was a reason I did this way around. Okay, right. That should run make. That should do us another build. That should at least not crash. Okay, that's a good sign. It didn't crash. So next up, we need to actually start comparing all these triangles and figuring out where they kind of intersect and which edges. There's probably an efficient way of doing this. However, most of my nav meshes are going to be very tiny, and I can probably get away with what's the name of it? Oh, what's the name of it? I've completely blanked on it. It's the it's the time thing. Yeah, when you're trying to say like the algorithmic. Because you got like n log and stuff like that. What's it called? Oh, is it just called time complexity? Yeah, there you go. You got things like constant time. Yeah, we are going. I think we're going quadratic time. Yeah, we're going quadratic time here with this. That's probably fine though. We're basically going to be going through the triangles, and then we're going to be comparing each. We're going to be going through the edges of the triangles and then comparing them to the edges of the other triangles, and then pairing them up. So at this point we have all of the hang on. At this point, okay, at this point we have all of the vertices together in a list now, and we can start comparing the triangles against one another to try and figure out where the edges kind of lie. Well, where the kind of neighbors lie. So we have the total number of triangles, so let's allocate our list of neighbors now. So it's going to be edge AB, BC, and CA. Okay, and then we want to initialize all of this back down to probably -1, just so we can use it to kind of indicate that there's nothing over the edge. And we've already got an index of there. We'll call it triangle index to make it clear what kind of index it is. And then I'm just going to initialize all of these to -1 to say that at the moment we're not aware of anything over that edge. Okay. And now we're going to loop back over the triangles. Thinking about it, we might be able to bring it down slightly from quadratic time. I don't know what time it's actually going to be, but it's going to be slightly less than quadratic time because the pairs of edges are going to be kind of like what's the term for this? They're going to be paired. They're going to be like equivalent. So yeah, we can actually skip anything earlier in the array than the second triangle, right? Oh yeah, I should also put a note in here to detect any degenerate triangles. And the reason for that is they'll break everything else. We've got kind of like triangles that, aren't, let's say lines or points instead. Okay, so we can start from the first triangle. Given that I don't actually seem to be using this number of triangles, I'm using the number of vertices like all of the time. I'm actually tempted to just, I'm going to replace that with total vertices. Oh, but no, we don't want to multiply this by 3 actually, because we can't straight up compare these as kind of like we can't just go over the indices. We actually need to go over the index pairs. That's fine. Okay, so we're going to see if we can find matches for all of the edges, and if we can, make a note of them, and this will, at this point, we'll also be able to detect if multiple triangles kind of are matches. Okay, so we use these, don't we? Let's cache the indices here. Man. Okay, this is pretty heavy stuff for so it's not really with it. Okay. Yeah, and then we grab our second triangle, the one we're comparing it to, and then we're going to do some comparisons. So ideally, 2 triangles will only ever match along a single edge. If they match along more than one, something's gone a bit wrong. But let me get Iceberg open and kind of just sort of like draw out what I'm actually trying to do here, kind of in terms of algorithm. So if we have 2 triangles here. What on earth are you on about? Select a valid. I am selecting a valid color, aren't I? What's not valid about this color? What? Huh? What do you want about A-Sprite? I feel like I'm taking crazy pills. Okay, does the pencil tool work? No. What? What is this on about? Huh? Fine, I'll open the existing image and use that one. See, this image works. I don't know. Anyway, so we've got a triangle, and the points are A, B, and C, and then we might find another triangle attached to it, and we need to detect that edge AB of this matches up with, say, edge BC of this one. So yeah, the pairs will always be kind of backwards, won't they? So this means that we could be matching any of the following. AB could be a match for BA, or it could be a match for, hang on, AC, or it could be a match for CB. Likewise, it could be BC, or it could be CA. There we go. So we have to detect any of these combinations. And there's probably a really neat way of doing this. Yeah, I mean, I could just make a list of all the edge sort of pairs. You know, like I could make a list of, like, I could split these triangles out into, you know, AB and BCA, but I don't know. I mean, allocating more memory and stuff. I don't know. Okay, so let's go through all these cases one by one. Are there any patterns actually we can kind of exploit here? No, it doesn't really look like it. So if I'm basically just gonna have to go for all of these and come up with the combinations, I think. Try not to make any mistakes because it'd be really, really hard to tell if I have. I think I've written this code before in a different project, and I seem to remember I came up with a better way of doing this. Yeah, so this has matched thing is just so that I can tell if we end up finding two ways the same triangle, well, multiple ways the same triangle kind of connects. So if you've got, say, like two triangles sitting on top of each other, it doesn't. Wait, is that even possible? Let me just draw this up. Let's see if I can find the hypothetical situation in which that happens. So, you know, if we had, say, you know, AB, let me switch to the pencil tool, and then we had, oh, hang on, let's do this differently. Let's write A, B, C, so A, B, C, and then we had, I don't know, yeah, so those are going in different directions, so let's match up. Is it in any way possible that AC could match any edge on this? I guess it could be if, yeah, if this was in the same location as this. Yeah, so it's not impossible. Yeah, let's carry on. Let's go put that check in there. Probably never going to hit it, but I'll put it in there anyway. Now, a strange property of this is it means that, yeah, I don't know what I was about to go with that. Hey, what's happening? What's happening? I'm currently confusing myself trying to write a nav mesh importer. How are you doing? Okay, that's that pair done. Next up, run to this. Now, the pattern here is now on BC, and the right hand side is the exact same. So I can actually copy all this down to here and just change all these to B. And then do the same down here with just the A to C. Okay. Oh, this is getting very repetitive. This isn't very good code, is it? It's the kind of code to get me fired. Do I have a helper in here to throw an error? No, I don't. I wonder why not. Anyway. Let's be more assertive with our error messages. Not they appear to, they do share multiple edges. Let's be properly assertive in here. Right, next thing we need to do is we actually need to make a record of which edges they're sharing. I've actually put that up here, so we actually need to go down the left-hand side, and I really wish I kept that that list of comments, that list of which order this was all in. Let's see. So AB, AC. Oh no, I've made this really hard for myself. No, wait, hang on, I've really screwed something up here because we're checking the same vertex of the same triangle twice. Oh no, I've really messed something up. Okay, let's make that list again. Oh, no, it's gone completely wrong. Okay, so yeah, the other triangle will be backwards, so just swap the two characters around. Hang on. That's it. Oh no. Man, I'm just way too wasted to be able to go like this. Okay, let's double check where we went wrong there. So I think what went a bit wrong was the fact that I need to kind of interpose these together like this. Wait, did I just mix the order up? I've got no idea. Right, so these should all be A down the left-hand side. Oh, wait, I've got one up there. Is that why I'm getting so confused? Oh, no. It's all going very wrong. I can't even write if statements anymore. Oh, God. Okay, that's a C, that's a C, that's a C, that's an A, that's an A, that's an A. And then let's double check the other side. So that should be B, C, A. Yeah, we've got this nice recurring pattern of BCA, BCA, BCA. This would have resulted in some very strange behavior like nav mesh edges not quite matching up. And would have probably been really hard to diagnose what was going wrong. So I'm glad to have caught it in there. Let's learn nothing and delete the comment right now. And then yeah, we're going to have the same logic on all of these. Something else that's just occurred to me. We don't just need to store which triangle that you're connecting to. We also need to store which edge of that triangle. So, how am I going to do that? I guess I could multiply it by 3. Yeah, so that way I'd have kind of like the 3 edges. That kind of works. Okay. Nav mesh edge shares a nav mesh face shares an edge multiple over. And rather than using face, we're going to use triangle because we're working in triangles at this point. This is one of these pieces of code that's going to be an absolute nightmare to write, but as soon as it's all put together, you just be able to just ignore, forget it's even there, just take it for granted almost. Been trying to think about how I actually want to use this in the engine once it's in there. And again, it's not going to be used in this game, but I kind of want to be able to have like multiple nav meshes and have them kind of like, say, attached to entities and able to move around, so you can have an elevator or something like that. We'll see. Okay, so now we're on edge 8C. And again, we're comparing against the... Oh, sorry, we're on CA, not AC. And we're comparing against the first edge of the second triangle, so we're going to keep that where it is. That's good. And again, we're still comparing against... No, hang on. What am I talking about? Okay. Yeah, we're actually comparing against the second edge of the second triangle and then the third edge. So that should be right. And now we're comparing against the second edge of the first triangle. Wow, this code is nightmarish. It'll be done soon though. Now, the first thing I'm going to do once I've written this is I'm just going to run it and see if it crashes. There's no point in trying to push any further until we at least have some idea as to whether this is at least appearing to work. Okay, run the build, see what happens. It didn't crash. Hey, that's something. That's good news, right? Okay, so now we have a list of which things connect to which edges. I think that was one of the things I had in this class, wasn't it? Yes. Okay, so the next thing we need to do is I need to ask whether, because I think I did like a remapping pass where I kind of removed all the vertices that weren't in use. I think I did. No, I haven't actually done that. Okay, all right. Okay, don't have a brain meltdown now. Okay, right. Yeah, I need to sort that out next. I need to add a sort of a remapping stage, but I think next up I'm going to get it actually generating some code. Where's the garbage code that outputs the... Ah, here we go. Yeah, so it's just a bunch of kind of like almost kind of like fprint style sort of methods. I also need to free this other memory I've created. And I should also be using this, not -1. What was this again? This was that, which was that. Okay. Oh, wait, I'm also going to have to import the header for that index type. Yeah, I'll sort that out. This is probably going to generate code that doesn't work, but it should still generate it, which is the important thing. Okay, so we export and we generate that, and we're going to have the footer that actually takes all those arrays and puts them together into a struct that we can then import into the file. Okay. One of the things I'm currently bringing in the object name here, and I'm not going to need that because it's always going to be navigation mesh, isn't it? So we can cut that out of there. Oh yeah, I remember writing this. It became an absolute nightmare. So many variables being passed into this and just no hope in hell of remembering where they all came from or where they all went. So let's just delete some until it stops crashing. Now one of the things that we did previously have in here is this kind of constructor function. The reason for that is that a polygonal mesh, like one you can see, actually imports textures that were converted by the TGA importer. But because they're being imported from a different C file, they're not available on the global scope. That's not going to be a problem here, as this is a nav mesh. It's just geometry. It doesn't import anything else. So we can remove that static there, and it should just be good to go like that. So we're going to have the number of triangles. So I think that's it. Total triangles, and then just going to repeat those two, and the rest of this we can get rid of it. That should generate code, but it won't currently compile, so we're missing headers. We'll fix that in a bit. Yeah, there we go. Yeah. So that appears to be working. So if I go through to, I think it's here. Yeah, look at this terrible, terrible code we're doing in here. Wait, did it not? Oh, did it not hold onto the file? Right, I'm just going to put a dirty hack in here to make it keep the C file around. Because at the moment it's an intermediate file, and Make is looking at it and going, well, we made that file during during the build. We don't need it anymore, so we're just going to get rid of it. There it is, there it is, there it is. We can... There it is. That's the... Sorry, it's this one. This one I mean for real. It's that. We just basically stick that into there and we say that as part of the build, we consider that temporary file to be one of the outputs. And it is going to do a total rebuild as a result of that. Because we changed the make file, it has to do a total rebuild just in case something, changed it wasn't previously aware of. And here we go, it's starting to output these files. Okay, let's just have a look at what they output because I'll make sure it looks good. Yeah, it did indeed actually create us a mesh and 6 triangles, is that about right? Let's get it open in Blender, let's have a look. Where's my nav mesh? Oh, I've hidden it. There it is. 1, 2, 3, 4, 5, 6. Yep, that's actually the right number of triangles. So next up, we're going to actually output the individual kind of like triangle sort of neighbor mapping. So this is basically as kind of like something that the engine can use as to kind of like quickly search through the nav mesh. It's just basically like a list of, if you're in triangle number 3, your neighbors are nobody, 4, and 1, for example. So we're just going to do something nice and simple like this. There is a complication here because we need to translate -1, which is what we're using in here, into kind of like a constant of index none. So oops, that wasn't going to work, was it? Yeah, this is all pretty simple so far. Okay, so we need to actually pull out the kind of like neighbor index from the array that we allocated further up. And then we need to check if it's -1. If it's -1, that means there's nothing over that edge. So we need to export this, otherwise we need to export the number. Let's see what that does. Okay, we know something definitely hasn't worked here because it thinks that every edge of every triangle is completely disconnected from every other triangle. We know that's obviously not right. And there is this loop here, and I'm wondering if oh yeah, I think I know what's happened. I'm not actually doing anything with these and stuff. Once I've actually figured out which edge it connects to, I'm not actually doing anything with it. I don't actually need to do that because I'm going to be initializing them down here. And then we need to do the kind of like the inverse case where we're kind of filling in the other. Yeah, so if we actually have a match for AB, we need to record what AB actually was. Okay, I think that's right. Yeah, well, I'm going to get rid of this optimization. It probably doesn't matter super much, and I'm a bit worried there's going to be a bug there. And we've still got a bunch of nons. That's not right. Oh no. What happens if I just put hard code number in here? Does it definitely come into the output? No, it doesn't. So the issue maybe isn't here, maybe it's here. Let's try hard coding one of these to something that might do something. Again, we've got nothing in there. That's weird. Okay, I bet we hardcode the number here. We're running all the way down till we find out where this is losing its data. What? That's not possible. Huh? How's it getting to there and not writing anything out? Okay, now we do something really silly. Let's comment all of this out and just make it write exactly what it finds. And I mean exactly. So it's no longer going to be capable. Oh wait, it's actually crashing. I think. Error 1. 2 nav mesh triangles share multiple edges. Do they? So let's check for duplicates here. Let's just collapse all these up and make sure I haven't done something stupid. AB, 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 BC, BC, BC. CA, CA, CA. And we got AB, BC, CA, AB, BC, CA, AB, BC, CA. So that looks right. Let's make it actually log out where it's hitting something, because I'm not convinced. Definitely got some kind of bug here. It might even be that our triangle generation has a bug in it. That's entirely possible. In fact, that's the most likely place I'm looking at right now. That doesn't need to set. That can never be hit. Okay, I'm just going to finish making this update, and then I'm going to just have a quick look up the top at the code that turns polygons into triangles. There's probably a bug there. Oh, hang on, we're not skipping the same triangle. Yeah, okay, we needed that skip in there. It's not just an optimization, it's actually critical to it working. Where did it fail? Where did it fail? Oh, it actually generated code. And it's all -1s. That's not good. That's not good. Something hasn't worked there. We'll figure it out. So again, all -1s, and definitely actually built the, yeah, definitely regenerated the file. Okay, there's actually something a bit weird I do here, but I found I had to do this to work around an annoying bug. You might notice it's actually writing kind of like a temp file, and then the make file renames it. And there's a good reason for that. And I found that if the if the C compilation failed, if the running of the exporter failed, it would still create a file with a timestamp newer than the source file it was based on. So make wouldn't know it had to run again. Okay, a navmesh triangle shares an edge with multiple other triangles. Does it now though? So let's double check this functionality here, make sure this is implemented correctly. So yeah, we're kind of like, oh God, I'm so fuzzy. Okay, so we're grabbing the first vertex, we're grabbing the second, we are then moving, sorry, we're grabbing the third, which is actually the second, we're then moving the third to the second and then reading the actual third. So that should be generating valid triangles, should be. Let's just, let's get this writing to the console so we can figure out what's going on. What's the command? fprintf, that's the one. This is taking a long time to implement. A lot more time than I was hoping it would. Haven't even gotten to the bit in the engine that actually runs this code yet. That doesn't look right, does it? What is happening there? We seem to be reading a lot of triangles in for a model that's only supposed to have 6. Okay, so we've got the face length. Let's just verify that we've got the right. Yeah, we need to verify here that we have the right. We have the right list of faces. Let's. Yeah, it resets it to 0 there, so that's definitely doing that. Let's just log out here how many vertices it thinks there are in the triangle, because there shouldn't be that many. Wait, what the heck is this? Ooh, what's this text down here? That looks like something's been printed, which shouldn't be. Hey, we got a 4 there. Let's try and make sense of whatever this is nonsense is it just printed there. Oh, hang on. Right. Okay, let's run this in a non-parallel situation just so we can make sense of the output. What is it outputting? Oh, I need to regen this. Okay, so it ran that 4 times. Why did it run that 4 times? Oh yeah, it's because we've got 3, hang on. We have 3 faces, each which has 4 vertices. So that should be running each of them twice. So why is it seemingly outputting millions and millions and millions and millions of... Wait, it's not now? What? Oh. No, that looks about right. Is it select putting nonsense? Yes, it is. I wonder where those weird negative numbers are coming from we saw earlier. Very strange. Anyway. So that looks right. It's, you know, I'm seeing the two shared first vertices. I'm seeing an unshared vertex, a shared vertex between those two triangles, and a final one. So that looks right. It looks like it's generating the right information. It's just that we're doing some kind of incorrect comparison here when we're trying to figure out if the two triangles kind of match up, I guess. We're definitely assigning this, aren't we? Yes. Definitely getting through all this and then just somehow not matching them up. Okay, so we need to start doing some debugging, I think, down here. So let's print out exactly what this code is seeing inside the triangles and see if we can figure out where it isn't matching. And then we're going to indent this one slightly just so we can more easily see where they are and aren't matching. Okay, yeah, we're getting some gibberish. We're getting gibberish in here again. I wonder how that's happening. Are we definitely writing these to the right places? I see what it is. Got brackets in the wrong place. Damn it. I think the size of the memory we're just allocating was completely wrong. Okay, that's still wrong, but it looks differently wrong. Okay, so we've got a number of triangles, and then we're adding a triangle for every vertex minus 2 and multiplying that by 3 to get the number of slots. Okay. And this shouldn't be index, this should be vertex. Yeah, okay, there we go. So yeah, it was first of all miscalculating the size of the array, and then it was putting the actual data in basically completely random places. So now we're getting a good healthy mix of triangles without neighbors and triangles with neighbors, and the numbers look plausible. So that's some progress. Next up, we need to get the headers imported so that these actually compile. So I think in the make file, I think I've just got a list of, yeah, here we go. I've got a place where we can just basically, because obviously the path is relative between this generated file and the header file we'll be importing. So we actually need to import from we actually need to do like a relative path thing, and it's just easiest to do that in the make file. It's got good tools for handling paths. Is it data structures, index? And I do then need to make a bit of a tweak to this because this needs to know to expect that. Yeah, so we've added 2 new headers, so those just need to be accounted for here. Just gonna put the index one first, given it's used by the navigation meshes. And then we need to push these down 1. Sorry, 2. And then we need to click 2 more copies of this. And yes, this is very, very cursed, what's going on right now. But it's code generation, it's usually pretty cursed. I've just changed the makefile, haven't I? Anyway, this should, in just a second, it should go pop and include the header file that we need. At which point it should start building. And all the red underline should disappear. Oh, it did build. I don't think Visual Studio Code's noticed though that we've imported the, yeah, it hasn't noticed that we've updated this file. That's quite surprising. It's normally quite on the ball, but no, it just hasn't noticed at all. That's interesting. Oh, there we go. It's because I am still looking for the old number of arguments, not the new number. Go. And okay, it's getting closer. It's getting closer. We have a duplicate const declaration. Oh yeah, so I put it in 2 places. That's interesting. I thought that in C you kind of had like one saying that, you know, it was a pointer that you can't change, and one of them was saying it's to data that you can't change. So maybe it doesn't quite work how I thought it did. Anyway, that's getting closer. So the next thing we need to do is I need to have a bit of a think about how I'm going to represent these in 3D space. Because obviously I can and I should include the positions of the vertices, but there's another aspect that needs to be considered, which is that the we're going to need to know exactly kind of where a character is on the plane. Yeah, so you've got like this, well, it's going to look more like that. We need to know when something has crossed an edge, and yeah, that's about all we need to know. And for some of the stuff I want to do, like I actually want to use the edges for kind of collision, so you'd have like this invisible plane like reaching up. And ideally kind of have like a normal facing that way or something, so I can do like basic edge collision. Okay, I'm just gonna look something up because it's a thing I've heard a lot, and it's something that sorry, it's is it barycentric or no idea. This is a very complex explanation of how it works. Here we go, this is the drawing I wanted. I just wanted to see if I could understand this. So it's almost kind of like a matrix, right? Sort of. And if you take the position of this vertex as like the first row, it's the second, it's the third row, and you're passing in a vector, and it's basically sort of interpolating between the points. Would that be useful to me? I'm not sure it actually would. Like, how do you detect when you say cross and do a projection? So I'm just going to do what I was going to do anyway. I'm basically going to I'm going to store the locations of the 3 vertices, and I am going to store a surface normal, so kind of pointing sort of this way, and then for the 3 edges I'm going to store a normal pointing along them, just so that I can use it to detect crossing and do like sliding collision against them. So in here, what information am I going to need? Well, whereas up until now all of these oh, my tracking stopped working, lol. Up until now all of these have been in separate arrays, because you tend to access them, you know, say you tend to kind of crawl the list of sort of neighboring edges on the nav mesh. The stuff to do with the actual physical location, you don't tend to do that. You tend to, go, well, I'm in this triangle, I am, colliding with it, whatever. So I'm going to make a struct for all of those. So it's going to be equally long-winded in its name. Oh, well, I've just had a hardware failure. Well, it's a good thing we're right at the end of the stream, isn't it? I'll carry on for the next couple of minutes, but the avatar is going away for a second. Oh no, it's good to know that I'm not the only one who's struggling today. Location of a triangle within a mesh used for navigation. The immutable location of a. Okay, so we're going to store the locations of the vertices. We can use that for kind of like doing sort of like plane projections. And we're going to store the surface normal. And for each vertex, a normal facing perpendicular for each edge. No, actually the following. Okay, 3 normals. Perpendicular to and the surface normal, BC and surface normal, and then CA. And we're going to use those for collision further on down the line. Very nice. So yeah, I'm just going to make a quick little array in here of those. Okay, and I guess for next time we need to actually populate that third property, and yeah, at which point we're then going to do some more work to actually add kind of like a navigation mesh component and figure out how the heck we're going to attach other entities to it. Well, it's been a day. Have a great evening, and I'll see you some other time.